Hey guys, Russ here. Welcome back to another fantastic chemistry video. And today we're going to look at this molecular formula right here and draw a Lewis structure from it. This is by request. Someone commented on one of my other videos, asked me to do this particular formula, so I said, why not? And here it is. If you have a question or you want me to work on a problem for you, go ahead and throw me a comment on this video. I'll be more than happy to. And while you're there, slap that like button, slap that subscribe button. Help me get to 1,000 subscribers before summer. That would be awesome. Thank you guys very much. All right. First things first, let's calculate unsaturation. Now unsaturation, remember, is are there any double bonds? Are there any triple bonds? Are there any rings? A normal acyclic hydrocarbon has the following formula. CnH to the 2n plus 2. That's a normal acyclic alkane. So we have 5 carbons, so it's going to be C5H to the 2 times 5 is 10, plus 2 is 12, 12. Now here we have 8 hydrogens and 2 chlorine. Chlorine is a hydrogen substitute. Now when you think about hydrogen substitutes, these are atoms that only need to make one bond to get to the octet. Fluorine, chlorine, bromine, iodine. Those are hydrogen substitutes. So when you're calculating unsaturation, they count as hydrogens, okay? I know it's a little confusing. Just remember, they need to make one bond. So we're trying to calculate the atoms that that need more than one bond, okay? So if you have 2 chlorine and 8 hydrogen, count that as 10 hydrogen. It's just part of the system. So you'll see why in a minute. So now we have 8 hydrogen plus 2 chlorine, so that adds up to be a total of 10 hydrogen. So that means I have 10 here. So I just put a 10 here. So I have 2 divided by 2 equals 1. Now what did I just do there? What I did was I subtracted the total number of hydrogen and hydrogen substitutes from here from what I should have had if it was a normal alkane. If I subtract these two, I get the value of 2. So that's 2 electrons essentially. So 2 electrons. I divide it by the total number of electrons that are in a bond. There's 2 electrons per bond. So I have 2 electrons and 2 electrons per bond. That means I have 1 unsaturation. I have a double bond, I have a ring, or I have a double bond or I have a ring. So I have some kind of double bond. I either have a carbon-carbon double bond or I have a ring. There's no oxygen in this molecule, so there's no carbonyl, for example. So this is the formula. So always divide by 2. Whatever the difference is between these two numbers, always divide by 2. And this number is how many rings or double bonds you have. So I know in this molecule, I have 1 double bond somewhere, or a ring. It could be a ring. So let's draw it as a double bond. I have 5 carbons. Make life easy. Put all 5 carbons in a row. I know I have a double bond, so just pick it. Just pick a place. Let's put it there. There you go. Put a double bond in. Could have been anywhere, but I chose to put it there. Now remember, carbon has to have 4 bonds. So this carbon has 2 bonds so far. It has to have 2 more because it has to have 1, 2, 3, 4 bonds. There's nothing here yet. I haven't put anything there yet, but I know there has to be something here. 1. This carbon has 1, 2, 1, 2, 3, and the dot eventually will be a bond, is 4. Again, these dots are just placeholders telling me that I need to make bonds here and better not forget. Better not forget. Okay? All right, so far, so good. I've got 1, 2, 3, 4, 5 carbons, so I can get rid of this. Don't need that anymore. I have 8 hydrogens and 2 chlorines. All right, leave the hydrogens to the very end. Trust me, it always works. Leave them to the end. So let's deal with chlorine. Well, chlorine, stick it on here somewhere. Chlorine only needs to make 1 bond, so put it on here. One more time. Chlorine makes 1 bond, put it on here. Anywhere, just pick a place. I'm going to put them here for no particular reason, but because it feels good. There you go. So there's one of my chlorines, and I don't know, how about here? for no particular reason, then it just felt good. And we got rid of those 2 chlorine. So now we only have hydrogen left. Now all we have left are 8 hydrogen. Hopefully we have 8 red dots. 1, 2, 3, 4, 5, 6, 7, 8. So now we know we're done. We have no more atoms left but hydrogen. We've got 8 red dots. We've got 8 hydrogens. Put the hydrogens in and you're done. I'm going to erase these dots just because it's going to make life easier to see. This formula, expanded formula, fits that molecular formula. And that's how I would do it. All right, guys, I hope this video was helpful. If you did, go ahead and slap that like button, hit that subscribe button, help me get to 1,000 subscribers, and go ahead and pop me a comment down below if you have any questions about organic chemistry or general chemistry or nursing chemistry or whatever. Just leave me a question down below. If I can get to it, I will certainly get to it for you and help you out. And with that, I want to wish you all good luck and good chemistry. We'll see you soon.